The broadcast is now starting. All attendees are in listen-only mode.
Good morning and good afternoon, everyone. Welcome to today's webinar, 3 Ways HOAP Databases Simplify Data Management. My name is Jennifer and I'll be your moderator today. Before we begin, there are just a few housekeeping items I'd like to review. Today's webinar is being recorded and you are currently in a listen-only mode. You may submit any questions you have throughout the webinar via the Q&A or chat function in the lower right corner of your console. You can also follow us on Twitter at MemSQL or live tweet us during the webinar using hashtag MemSQLWebinar. We will address everyone's questions towards the end of today's presentation. After today's webinar, you will receive a follow-up email with a link to the recording and slides. And if you wish to contact us, please send us an email to team@memsql.com. So let's begin today's presentation on 3 ways HOAP databases can help you to simplify data management. We know as data grows and usage increases, so does the need for a more scalable database architecture. Old legacy databases just don't provide the flexibility and performance required for new modern applications, and NoSQL databases don't have the robust features companies like yours need. We believe the type of architecture required for modern applications are hybrid, operational, and analytic processing, otherwise referenced as HOAP. Today, we'll be discussing how these types of HOAP databases deliver reduced time to insights for your business's most critical data. With that said, I'd like to introduce today's 2 speakers, Matt Aslett and Mike Boyarsky. Matt is the Research Vice President with 451 Research's Data, AI, and Analytics channel, including operational and analytic databases, Hadoop, as well as data science and analytics, machine learning, and AI. Matt's primary area of focus currently includes distributed data management, data catalogs, business intelligence and analytics, data science management, and enterprise knowledge graphs. Welcome, Matt. Mike is MemSQL's Senior Director of Product Marketing. He has over 15 years experience working with database and business intelligence technologies, with expertise in real-time analytics solutions deployed at some of the world's leading organizations. Welcome, Mike. Thank you guys both for joining us. You have the floor, Mike.
Awesome. Thank you, Jennifer, and thanks, Matt, for joining us. We've got a great topic today, and I'm really excited to have Matt come and join us and talk about some of the data transformation drivers that are happening, and also going into more use case content, talk about what's ultimately driving this sort of emerging class of database that is called HOAP from the perspective of the 451 research team. So Matt's going to give an overview of the market landscape of the HOAP database space. It is an emerging market. It's an exciting new category. So we're happy to have Matt talk about what's going on in that space. But then I will then spend a little bit of time talking about MemSQL, providing a brief overview for those that are new to our technology, to spend a couple minutes on the architecture, and then also spending some time on actual customer deployments, so you can get a handle on how we work and how we benefit customers. So with that, we'll hand it over to Matt, and he will take us through some of the latest research and perspective of the HOAP database market. Matt?
Thanks, Mike, and yeah, thank you everyone for joining us on today's webinar. It should be, as Mike said, an interesting topic. Clearly, you know, one of the key areas that we see that's shaping the market as things move forward. So before I get into that, just to briefly give you an introduction to 451 Research for anybody who's not come across the company before. So we're an IT research and advisory company. We've been around since 2000. We've got a couple of hundred employees, including over 120 analysts and over 1,000 clients, which includes technology and service providers, as well as corporate advisory, finance, professional services, and IT decision makers. And the last thing I'll point to on this slide is perhaps the most important. That's the next one: 85,000 plus IT professionals, business users, and consumers in our research community. So these are people that are not direct clients of 451 Research, although some of them work for companies that are, but they are home lives, obviously, and they help shape our view on the world by taking part in interviews and are an increasingly important part as I say, shaping our view on the market. And you'll see some of that as we go through the content today. So, if we think about the changes that are happening in the database market and the data management market overall, one of the key trends that we see that is shaping the world is this concept of being data-driven. And we see that most companies are increasing their investment in data processing and analytics and machine learning software with a desire to become more data-driven, and the data and the rapid processing of data is really a key driver in enabling companies to grasp the opportunities that are presented by things like digital transformation in order to deliver greater operational efficiencies and competitive advantage. Now, there's a lot of buzzwords in that, so there's a lot to unpack. We'll start with digital transformation. It's one of those topics. I often say it's okay to roll your eyes when people start talking about digital transformation, but it is a very real thing, and we do see that an increasing number of companies are formally, putting into practice digital transformation projects with a view to being more, as I say, driving competitive advantage and operating more efficiently. And the reason why this is significant is that the organizations that aren't going through those processes, that transformational journey, are really at significant risk of being left behind, both by their existing competitors who are transforming themselves, and of course, at the hands of emerging startups who have the potential to disrupt the industry. So this is some data that comes from that panel of experts I talked about earlier, and this is from a survey we ran earlier this year from our Voice of the Enterprise Digital Pulse, and we were asking people about where they stand in terms of their digital transformation journey. And as you can see, we actually see that 40% of respondents to this particular survey said they are actually in what we would call the execution stage. They already have a formal strategy and they're actively digitizing their business processes or assets. In addition to that, we saw about 27% are in the evaluation stage, so they're planning, researching, and thinking about developing a digital transformation strategy, and a further 20% are considering, but have no formal plan. So it's the 14% that those that have no strategy, no current ongoing digital transformation strategy, that we think are significantly at risk. And actually, you could make a good case that it's actually the 34% who are not actually even evaluating yet that have the potential to be overcome by, as I said, both the existing competitors and disruptive market entrants. Now, if we think about what companies are actually doing when they're going through this digital transformational journey, obviously it's one thing to say you're transforming; it's another thing to actually do it. We have also, through our surveys, able to identify some key trends in terms of what separates the leaders, so those in that 40% category that are executing, and the laggards, those in the 14% category that are not doing anything yet. And we do begin to see some very distinct trends in terms of adoption of newer technologies, in terms of the strategies they're taking. So this is again comes from a report. Actually, this was from late last year. But just to pick out some key things like adoption of AI machine learning for intelligent business applications. 53% of leaders are doing that versus only 29% of laggards. Cloud-based adoption of cloud-based infrastructure. 41% of the leaders versus 28% of laggards. Or investment in intelligent personalization. Again, the same thing. And we were actually just wrapped up a Voice of the Enterprise data and analytics survey, which we'll be publishing in the next couple of weeks. And we see very similar things, again, around data platforms and analytics choice in terms of the adoption of, adoption of cloud, adoption of emerging and new approaches to data processing. So this is an area where we're developing our own data and analysis around, and we'll have more to bring you with that, as I say, in a few weeks. But, what we see across all the surveys we do is a similar story, that those that are investing in advanced technologies are also those that are rapidly, as I say, transforming themselves, and therefore stand the best chance of maintaining their competitive advantage versus their rivals. Now, in terms of, you think about this from an application standpoint, and this then having implications on obviously the data processing requirements. What we see is it's all about a shift from traditional systems of record, internal transactional data applications focused on process efficiency, towards what we talk about in terms of systems of engagement, customer-facing applications that are interactive and deliver personalized experiences, and the applications themselves are designed to be disruptive. And the other element that isn't on this particular image, but that is important here, is what we talk about, not just systems of engagement, but systems of intelligence. So the things like machine learning and AI, which actually drive those interactive, personalized experiences. And that, if we think about the applications in that way, that has significant implications in terms of data processing requirements and data processing choices. So we think about the traditional approach to data processing. Clearly, it's always been about transactional processing for those systems of record applications that we talked about in the previous slide, and then OLAP analytic processing for the analytics to deliver business intelligence based on that same data, but running on separate databases with ETL processes moving data in between the two. And the reason for that, I think, in some ways, it's becoming easier. This is just the assumed wisdom. This is how you do data processing for both transactions and analytics. But of course, the reasons for that are historically down to performance and the performance limitations of being able to run transactions and analytic processing on the same database. In many instances, we see actually organizations are using the same version, the same database products, but they've been tuned differently and able to deliver on the requirements of each of those application types. And as I said, that ETL process to move data in between the two. Now that historically, has worked, pretty well. There's a reason why people have continued to do that for many, many years. But if we're talking about interactive applications, personalized applications, then that time that it takes to transform and load data in between the two systems then presents a challenge. And this is fundamentally what we see as driving demand for what we call hybrid operational and analytic processing, or HOAP, and supporting those systems of engagement that we talked about in the last slide. Now, just to be clear about HOAP and hybrid operational and analytic processing, there are obviously other terms that are used in the industry to describe the same thing. Some talk about hybrid transactional analytic processing. We prefer HOAP in some ways because it just sounds better, but also because, and this is quite an important point, that whilst all transactional workloads are operational, not all operational workloads are transactional, and particularly where we see obviously NoSQL databases clearly have a role to play in the environment going forward. Then the concern here is about the operational applications, which may or may not be transactional. So that's just to explain why we use a different term. By and large, we're talking about the same thing, just for the avoidance of confusion. And we see that this is, clearly very early stages of adoption and maturity, but we actually do see, a big potential uptake for hybrid operational analytic processing. And this is, a statement we put out last year, which received, quite a lot of interest in terms of the idea that more than 30% of new database revenue will be associated with hybrid operational and analytic processing by 2021. I'll go on to explain how we came to that number in a bit more detail later on. But the real reason that we see that adoption is down to the emergence of new use cases, which are driven by, as I said, this move towards sort of systems of engagement. So again, if we think about this in terms of, as I said, the historical sort of database usage, you've got your online transaction processing, dealing with data from your systems of record, traditional enterprise operational applications, ERP, CRM, SCM, etc. About processing operational data. Traditionally, then you'd have ETL into the OLAP databases for running systems of analysis, traditional enterprise analytic applications, things like data warehousing, data marts, BI reporting, and potentially data science. Analyzing, for the most part, historical data. As we said, with hybrid operational and analytic processing, it's all about those engagement applications. So this is about emerging enterprise operational applications that can deliver content and things like recommendations and personalized offers, and perform things like real-time fraud analysis at the point of processing. So analyzing operational data in order to deliver a particular service, including things like recommendations and personalization, for example, at the point of engagement with the end user. Now, one thing just to clarify on that, is because we are talking about operational analytics, but we're not seeing this as a replacement for perhaps the data warehouse or your big data analytics system. There is still a requirement for both. If we think about, as I talked about, the data warehouse originally kind of developed almost as a workaround for the performance limitations of operational data processing. The performance improvements that we've seen over the years in memory processing, processor performance improvements enable hybrid and operational analytic processing, but they don't completely eradicate the need for something like a big data platform to perform large-scale analytics. But what it does do is it it reduces the cost and the complexity of doing things like extended analytic services. So things like ad hoc data warehousing, real-time analytics, supporting the kind of applications that I talked about on the previous slide. Now, there's a number of implications in relation to this, and we talked in the title of the webinar here around sort of three considerations. So we see there's three implications in terms of data processing, and then three requirements, or there's more than three, but three fundamental requirements for the database capabilities to support these applications. So in terms of the kind of the application implications, the first being real time. It's all about real time interaction. Customers expect immediate information and content. So to put it in a retail context, because that's something everyone can easily understand. You log on to your favorite e-commerce site, and these days you expect to immediately be given some recommendations about things you might want to buy based on things you purchased before. You don't have to wait for that information to be delivered, and if you do, the chances are you'll go somewhere else. It's just the expectation is it is there instantaneously as you log into that environment. It also it needs to be responsive both to the individual and to the interaction. So it's not just, this I think is important, it's not just static content that's served up immediately and served up to you in a fast manner. It is reactive to the things that you've just browsed, the things that you've just you bought maybe just a second ago, in terms of things not just about recommendations, but also perhaps the information in terms of when you can expect that delivery, or maybe you've just made an error and you need to figure out how you can cancel that order and order something else. That information is all available to you immediately because of that being responsive to not just you as the purchaser and your historical information, but the actions that you literally just performed on that site. And the third thing is agile. So it needs to be contextual. It needs to respond, not just to who you are and what you're trying to do, but the way in which you're engaging with that organization. Be it obviously the most obvious is if you're engaging through a mobile device versus a laptop, and the interactions, the way in which people interact with again, let's say an e-commerce application, depending on if they're on the move, or actually potentially even in a store, or sat in their own home, are very different, and that needs to be taken into account, both in terms of the user interface in particular, but also in terms of the information and the things like recommendations that are presented to that user. So the requirements that are associated with this from a data processing perspective. The first and most obvious, and we mentioned this already, is performance. I mean, we've seen those performance improvements, both in terms of in-memory data processing, in terms of processor performance, in order to support both operational and analytic workloads simultaneously. And that's something clearly which is improving all the time, but clearly over the last sort of 5 years in particular, we've reached this threshold where it's now much more reasonably reasonable to expect systems to actually support these kind of applications, and clearly those applications are there being developed to take advantage of that. The second thing we'd see is kind of simplicity. So we are talking about multifunctional systems, but they should be designed to serve those multifunctional purposes by design. So there is clearly a lot of existing data processing database products and services that are available out there on the market, and many of those have now sort of operational and analytic processing capabilities being added to them. Not to say that they don't serve a purpose, but we do see that if you're talking about the really the most significant performance requirements, then you're really probably looking for something that's been designed from scratch specifically to serve that purpose, and doesn't necessarily come with sort of the baggage of 40-50 years of sort of legacy approaches. And the third thing, obviously, we see is cost effectiveness. Overall, we see a lot of organizations are clearly looking to lower their costs of data processing, and of course their overall infrastructure. They're doing that through things like the cloud. But hybrid operational analytic processing has a potential role to play in that, in terms of for particular the applications and workloads that we're talking about here, for the possibility to consolidate some of that workload, so at the very least eradicate for those certain applications some of that sort of ETL overhead. Now, you put all those things together, and we talked about the use cases, we talked about the requirements, we talked about the needs, we talked about the technologies that are driving this. So where is the market, and where is it going? Well, if you look at the overall database market, and this is some numbers we actually created in 2017, so they're based on 2016 revenue. We're in the process of updating this. Unfortunately, it wasn't quite ready in time for this webinar, but we were looking at a continuation of these trends rather than anything significantly different. But if we look at the overall database market, we see that about 35% of that overall went in 2016 went to what we would consider OLAP, analytic database, data warehouse environments, and about 65% of revenue was driven by products that support operational applications, of which the vast majority is what we would consider mainstream traditional OLTP database environments, and just 1.6% was generated by hybrid operational analytic processing databases. Now, you could look at this and say, well, this doesn't seem that important, then why are we bothering to talk about it? But the important thing you have to take into account here is these numbers include maintenance revenue for existing database deployments, the vast majority of which were not designed to support hybrid operational analytic processing. They were designed for the old traditional world of OLTP and OLAP. So perhaps what we did was to perhaps get a better picture of where HOAP fits, is to exclude the kind of ongoing maintenance revenue. Let's just focus on the new revenue. New revenue is being driven by new projects for databases. And if we take a look at the numbers, then it looks a little bit different. So we've got, again, OLAP around 30%, operational, the majority of the market, but HOAP now up around 10% of actually new database revenue in 2016. So already, quite a decent size of the market. And if we extrapolate forward, based on our models, what our end users tell us in terms of the applications they're looking to deploy, the workloads they're looking to run, the databases they're looking to run, then we see that actually by 2021, this is where we get this figure I talked about earlier, where we think that close to 31% of the overall database market could be attributable to for new database revenue could be attributable to hybrid operational and analytic processing. So it has the potential to be a significant portion of the market, especially for, obviously, as we say, for new database products. Obviously, the existing products that weren't designed for HOAP will continue on their existing databases, although many of those will be retired over time. The other thing to highlight here, and this is just to reiterate the point I made earlier, is that we see that hybrid operational analytic processing, the way we think about it, is as a subset of the operational database market. There is still this separate requirement for OLAP, data warehousing, analytic database products and services. It's still about a third of the market. For longer term analytics projects, rather than this real-time analytic processing, which can be supported by HOAP. And one last thing, obviously, that it's important in terms of all of this is that HOAP is after all just the foundation. So this image, I'm sure people will recognise this. Obviously, I'm calling in today from the UK, and this is actually what is known as the fourth plinth in London's Trafalgar Square. And as anyone who's been to Trafalgar Square will know, there's lots of statues, but in where there should be a statue, instead there's this empty plinth, which has been there for well over 100 years. I think obviously originally it was designed to have a statue of somebody on it. For whatever reason, it never got built, and we've never amongst us figured out what we should put on there instead. Maybe a couple of years we have a bit of a national debate about it. Nothing ever gets done. It's been used actually for some interesting things like art installations and things like that over the years, but for the most part has remained empty. And yeah, the reason I use this image is it kind of reflective in a way of the opportunity, the potential for hybrid operational analytic processing, but it needs something else. And what we think about the greater adoption of hybrid operational analytic processing will clearly be delivered by the applications that I talked about earlier to take advantage of that technology. And we see that as those applications run through and people bring them to market, the demand therefore for the data processing capabilities to support those applications will begin to build as well. And we think that there's a good chance for a snowball effect here, which is going to drive significant change in the database market. So we're still at the very early stages of that, but lots and lots of potential. So this is a fairly rapid run through the database market and some of the drivers and technologies and needs that we see. Obviously, there's many sort of moving pieces here, and I think that's why it makes it a really interesting area to cover. But just to focus on the conclusions, as we see it at the moment, as we said, hybrid operational and analytic processing database workloads we think are set to grow significantly, especially for new database deployments, and that's all been driven by the delivery of automated systems of engagement and the underlying systems of intelligence that support them. And one of the key things we see that is being used to support is improved customer engagement and enabling operational analysis. The database performance, the database requirements that we see to support those applications include things like performance to support both operational and analytics workloads simultaneously, as well as simplicity. We're talking about multifunction design, but we think the greater performance is delivered when those systems are developed fit for purpose, but also cost effectiveness. There's an opportunity here to lower data processing and overall infrastructure costs. We do see that development of new enterprise operational applications that is reliant on things like recommendations, personalized content, personalized offers, real-time fraud analysis, for example, will drive the continued and ongoing adoption and use of memory-optimized hybrid operational analytic processing databases. So as I say, we're still at the very early stages of this. Those applications are being developed and deployed, and those will continue to drive demand for the technologies we've described here. So there's, as I say, a fairly brief kind of overview of the market and the trends as we see it. Happy to take questions on that at the end of the webinar here. But for now, I will hand you over to Mike, who's going to talk about MemSQL, obviously, and where it fits in the landscape that we've just described. So for now, thank you very much. Mike, I'm not sure if you're there or if you're on mute.
Thanks, Matt, for that. Yes, I was on mute. So thanks again for that introduction and sort of context around what's happening in the marketplace with some research notes and also commentary about some of the applications that are driving this new architecture. So we'll spend the rest of the session today about 10 minutes or so talking about MemSQL for those that are new to the product and some of our case studies and customer use cases. So let's get into a little bit about who MemSQL is. We are the no limits database. We'll talk a little bit about how we can claim this with some of our architecture. We are built ultimately for modern applications and analytical systems, and we're able to deliver no limits because of our extreme performance, the fact that we believe that ingestion and query performance are paramount to any sort of modern environment. We are massively scalable. That means it's scale out. So we are fully distributed. We take advantage of commodity hardware. We do believe fully in the relational SQL model. So we are very easy, familiar with ANSI SQL support. And we were built in the cloud era. So we are very much a cloud native platform. We have many customers that run us on a multitude of clouds. But we also have an on-premise version of our product. So essentially we can run anywhere. And then our focus here is to provide superior price performance. So we want organizations to get the best performance they can get without having to spend some of the pricing that folks are familiar with in the sort of legacy database market. So how does MemSQL deliver on this performance, and what is the underlying architecture? It is fundamentally a converged architecture, and that means we are able to ingest data through a streaming and or bulk load processing model. So that means we take advantage of lock-free architectures. We can ingest data immediately from message queues or change data capture processes. So data can stream into the platform, or if you want to do bulk loading as well, that's also supported. But when we talk about new modern architectures, we believe streaming or real-time ingestion is important. And then once the data lands into MemSQL, we have essentially two engines. And so to the end user, it just is a SQL prompt, but under the covers, we can manage the data or process the data in memory. We have a memory optimized table that's in row store format. So think transactions, think very fast lookups, queries, etc., all in memory. And then we also take advantage of disk, and that disk architecture stores the data in column store format. So you get all that advantages of compression of your data and very fast scans and lookups. So what you're getting with MemSQL is essentially two databases in one. And what that delivers to your application is a SQL endpoint that you can run analytics, transactions, all in one unified system. We built this because of the recognition that architectures have been evolving. So this was a view of an architecture that existed many years ago and does still exist in some areas where you're extracting data from an application using an ETL process. You're batching that into a data warehouse, and that data warehouse is then serving reports and dashboards for business users. And then we recognize that there was performance and latency in this process, whether it's the ingestion routines or the data warehouse itself was starting to slow down. So in order to address that, we noticed organizations starting to silo the data, starting to break it up into specialty stores to deliver a number or multitude of requirements. In some cases, that might be a real-time requirement. In other cases, it might be a faster lookup capability. Maybe it's a search capability. The net of all of this is that the architecture and infrastructure for IT organizations to enable data-driven decision-making is becoming super complex and very expensive and hard to manage. So we believe the future is in converging. We think that going to a database platform that can support multiple workloads, transactions, real-time ingestion, with analytics is ultimately going to give you the best architecture. And so that architecture is more simplified, it's more unified, but also it has the familiarity of your traditional database because it's a SQL-based system. So we can handle semi-structured or documents or even, of course, relational structured data. And so this is the ultimate architecture, we think, to deliver high performance. So because of this, we think and have seen in our customers that delivering very fast performance at a dramatically lower cost, especially over legacy database providers, is the value add or the benefit of adopting a new HOAP style architecture such as MemSQL. So I'm going to now spend a little bit of time talking about some of our case studies. We have a number of financial service companies. In this example, this is a top 5 global bank. We'd love to highlight the logo and who this is, but obviously that's not something that's always possible with the competitive environment with the banking institutions. And in this case, this was a multiple deployments, ultimately driving real-time decision making. So they were looking to avoid risk. They were supporting algorithmic trading and also real-time fraud detection. So multiple use cases or deployments into one single customer environment. And some of the highlights from this particular environment was the reduction in the hardware footprint. So the advantage of MemSQL, that's one of those details that's hard to describe until you use the product, is just how efficient the architecture and the hardware consumption is. We often see customers reducing their spend in hardware dramatically because the architecture was built with efficiency in mind. They also were able to consolidate their data management platform to a single vendor, which provided advantages from support and whatnot. And then ultimately they replaced some technologies that they were no longer looking to invest in, including Netezza and Teradata. Within the Comcast has been a great customer of ours, and they're using us also in a number of different use cases, ad analytics, personalization of content, and then streaming media analytics. So this is the idea of essentially providing telemetry on fast moving data and data that's constantly in motion. And one of the great examples in this application is their DVR application. So they are tracking all of the interactions that are occurring on the box. So whether it's changing channels, pausing, stopping, moving from one channel to another, collecting that data and then using that information to help with some of their advertising performance. They also use some of this data to help with customer service. So they can actually identify issues based on the types of interactions that customers are doing with their set-top boxes in terms of setting them up and configuring them, that they will know actually that the customer's experiencing a problem, and they will proactively offer service to address those problems. So a really interesting spectrum of use cases. Most of the Comcast team are using MemSQL for more real-time applications and analytic processing. Another great example is Uber. Uber uses us for essentially their back office or operational analytics programs. So they were looking for a platform that could give them very fast responsive queries of geospatial data. And so what this application does is it gives their essentially their managers of their various geographies and various driving centers a view into the operations of their business. So that it has a number of KPIs and metrics that allow them to know how their various regions are performing. This is all on live data, so you can imagine how active Uber is as a 24/7 operation. And the team here was able to essentially stand up a platform of MemSQL to support a number of concurrent access users. So there was a roughly about 3,500 or so users that could touch the system concurrently. So they needed high concurrency, they needed sub-second latency. They really wanted to provide up to the millisecond response on millions of rows of data. And again, this is a always on service. So this is where operational excellence and that the service can't go down but also high performance so that they can get the queries delivered appropriately. We also had a really interesting deployment with a US utility company. You would call this maybe a traditional IoT analytics use case where they're looking to measure and monitor their equipment, whether these are equipments that are used to drill and explore in the energy space, or equipment that's used to essentially provide smart meter services, so measuring consumption of energy resources. So in this one particular example that it'll drill into was very interesting around how they essentially used MemSQL to ingest data on their drill bit systems. So they were able to identify various temperature, vibration, other control points to identify potential outage or issues that may result in a breakage of that equipment. And so preventing that outage saved them a lot of money. And so it ultimately looked to be about $1 million per day in operating costs and avoiding a particular outage such as this. And they were using a system of SAP, their HANA platform, and they saw dramatic savings in no longer having to leverage that platform. And they also had an existing SaaS PMML predictive model that was easy to move or port over into the MemSQL platform. And that's largely because we are a relational SQL database. So we're just like any other traditional database out there. We look and feel like relational ANSI SQL, but we're on a distributed scale-out system that leverages memory and disk appropriately. And then lastly, we have a really interesting deployment within a government agency group that's using us to essentially modernize their legacy database platform. So they were on a traditional legacy environment that was not performing, and they looked to increase that performance in two dimensions. One was query performance, and the other was concurrency. So they were having a number of users accessing the system at the same time, and that legacy system was just no longer performing. So they looked to a number of providers, cloud-based, on-prem, specialized data warehouse type vendors, and they chose MemSQL ultimately for the performance. So they got really dramatic query performance, and they were also able to deliver consistent performance to all of their concurrent users. So they had about 12,000 or so users that they were delivering dashboards to, and that's what drove their decision to go to MemSQL, was the performance and the scale to deliver this service to their business. Super. So that wraps up in terms of the content today. I think we do have a few minutes to go over some questions if there are any. So I'll hand it over to Jennifer.
Great. Thank you, Matt, and thank you, Mike, for the presentation today. So we just have a couple minutes, so let's answer a few questions from the audience. As a reminder, you may submit questions through the Q&A function located in the lower right side of your console, or tweet us using hashtag #MemSQLwebinar. So I see that some questions have come in, so let's start with this one. How are the underlying files of the HOAP data engine different from an OLTP perspective?
Anybody can answer this one. So how are
Mike, go ahead from MemSQL perspective.
Files of the HOAP data engine different from OLTP? They're not. They're actually, the files themselves are not any different. We, at least from a MemSQL perspective, we built our product based on the foundations of relational database architecture. So that means storing data in table formats with, classic database structures, and then we log everything to disk. That log can be backed up. It can be read back in case of an outage. So very traditional view. The only difference would be that some of the data is processed in memory, some of it's processed on disk, and so that's where you get the performance. But how the data is stored and structured is, I would consider it to be very similar to your traditional solutions.
Thank you, Mike. So next question, how can this be used for a cloud-based application?
Yeah, I'll comment on from the MemSQL perspective. We see actually a number of customers that are building completely cloud native applications using MemSQL. So there's no limitation in terms of where your application gets deployed. I think a lot of the newer applications are natively being built on the cloud for scale out and agility and whatnot, and sort of the elasticity. So MemSQL is, I think we've roughly got 30 to 40% of our customers are running natively on some public cloud. And they're doing that because of the agility they get, some of the elasticity they get. And so there's nothing sort of about the HOAP architecture that would prevent or limit you from doing this same compute on premise or in the cloud. So we're pretty agnostic.
Yeah, absolutely. As I said, and I think this would be the same for all vendors in this space. Clearly, everyone enabling cloud-based adoption to the extent that customers are demanding it, which they are, and that, as Mike said, they're particularly for a lot of new application development is happening clearly in the cloud and deployment as well. And so, yes, I think that's one thing we see a correlation between new application development, new architectures being adopted, and cloud adoption. So yes, no, definitely, it's not only an option; it's one that a lot of companies are taking.
Thanks, guys. So one last question: does MemSQL solve indexing and partitioning functions similar to SQL?
Yes. I wish it was. Yeah. So we have indexing structures. We have indexing structures that are specific to the in-memory table structure as well as the column store structure, very similar to what you would expect from, I think when you say SQL, maybe you're saying SQL Server, but that same approach would be used by other traditional databases as well. So again, we have attributes of our product that are very familiar. The difference with MemSQL is that it was built from the very first line of code to be distributed, to be scale out, and to take advantage of memory as appropriate. So that's the difference between our architectures and the products that were built 30 or 40 years ago.
Great, thank you guys. So thank you everybody for the questions. Unfortunately, that's all the time we have today. For those of you with questions we did not get a chance to address, we will follow up with you directly after today's webinar. So I just want to thank Matt and Mike and each of you guys for attending today. Just a reminder, we will be sending you a follow-up email with a link to today's recording and slides. If you have any questions in the future, feel free to send us an email to team@memsql.com. So we invite you to learn more about MemSQL by checking out our website. It's just memsql.com, or you can give us a try at the URL that's on your screen right now, go.memsql.com/enterprise-trial-6.5. Additionally, you can learn more about 451 Research on their website, 451research.com, or follow them at 451 Research, or follow Matt directly at MASLETT. Again, thank you guys for participating and have a great remainder of your day. Bye.